Okay guys, so one of the things that was in your objectives of chapter 2 was make sure that you understand the parts of an atom, and then you can draw an atom and some of the structural things of that. So I know you've worked with this before, so we're going to go ahead and take a look at a lithium. Alright, so what does it take to be a lithium? Well, lithium's element number 3, so it's got to have 3 protons. Now this is not a neutral lithium atom, and also I can turn on the stability thing. That would be an unstable nucleus. What does that mean? This nucleus would be giving off radiation. It might go through a radioactive decay and turn into an actual other element, so it could go through fission. So if we start adding some neutrons in there, add enough of them, that actually holds it together. We're not going to go through in a lot of detail why the neutrons make a nucleus stable, but what happens is protons are positively charged, and there's a tremendous amount of repulsion. There's this thing called strong force that only exists down at the atomic level for these really small particles. And so any proton or neutron, as they get really close to each other, if they get close enough, there's this very strong attractive force. But it doesn't occur if they're very far apart. So if they're more than, say, the width of a proton or neutron apart, the force doesn't really exist. But when you get outside of that, when you get inside of that distance, it's really strong. Neutrons have no repulsion to them. They're neutral. So what the neutrons do is they add to the strong force, but they don't add in repulsion. So if you get enough neutrons to overcome the proton's electrostatic repulsion, because like charges are repelled, then you'll get a stable nucleus. And basically you need 1 neutron for every proton until you get up to about element 20. After that, now we got to start adding some more neutrons, and the atoms get even heavier. Things that you need to know. Okay, you need to know the charge. Protons positive, neutrons neutral, electrons negative. And you need to know the relative mass. Now right now this is a stable lithium nuclei, but it's an ion. It would have a charge in there. So how do we get rid of this plus thing right here? Now also we can kind of open this up, and it shows you what the mass number is. You're required to know what the mass number means. Mass number is the number, strictly the counting number of protons and neutrons. Now we've set this up when we were doing our atomic scale, so that a proton or a neutron weighs about what we call 1 atomic mass unit. Okay? So if you have something with a mass number of 6, it's going to have an atomic mass of about 6 AMUs. Now what we're going to do is we're going to try to make this become a lithium atom, not a lithium ion. So, let me go on here. What do we need? Well, we need some electrons. Okay, there you go. This would be a nice drawing of a lithium, a neutral lithium atom. Notice the charge went to 0. Didn't affect the mass number at all. Why is that? Electrons add very little mass. They're 1/1836th the mass of a proton or neutron. So electrons really don't do much to our mass. That's all there is to it. Now, what are you going to have to be able to do with these things? Let me go back here. You have to be able to represent, and this will do this right here, our different isotopes. So that was lithium, what we'd say 6. What does that mean? It's got an atomic or a mass number of 6. What does that tell you? Well, let's take a look. Okay, so now we've got our 6 protons. It's not stable. We need some neutrons to glue that together. Let's put them in there. Okay, now I've got a stable nucleus. Take a look what happened right there. This number down here is the atomic number. That's the number of protons. It wasn't until almost 1920 that we discovered that the number of protons is what gives an atom its identity. So what makes lithium lithium is any atom that has exactly 3 protons. There's nothing else. It's just what the protons are. So what's this number 6? Well, that's the total number of particles in the nucleus that are adding mass, and so that means if I've got a mass number of 6, an atomic number of 3, okay, that means I have to have 3 neutrons. So all you have to do to figure out the neutrons is subtract. Over here, we put the charge, okay? Right now, it's got a +3 charge because all I've got is protons. So let's go back and change this. 1, 2, 3 electrons. Now we've got our thing right here. Then we've got 0 as our actual charge on this. So we've got the neutral lithium atom. So I'm going to ask you a question. We'll play a little Blue's Clues here. So if you ever watch that show, they deliberately did this thing where they'd ask you a question and they stop and they wouldn't say anything. That's called wait time. You're letting the kids have a little bit of time to answer the question. So what are ions? Ions are things that atoms that have a charge. It can be positive, it can be negative. The most common charge for lithium is +1. So that's the most common lithium ion. So what do you do to get a +1 lithium ion? Well, it's simple. Just add a positive charge, right? Well, let's see. So I'm adding in a proton. Whoops. What happened? Okay, you can't make any kind of ions by adding or subtracting protons. That doesn't happen. It's very, very difficult to take particles out of the nucleus. You need a superconducting super collider to do that, or you can have radioactive decay, which we don't want to do that in the lab. Okay, so I'd like to keep you radiation free there. So that's not how that would happen. So let's take that proton back out. How in the world do you make a lithium with a +1 charge? The only way we can make ions, now we got lithium with a +1 charge, it's by gaining or losing electrons. So if I were to get, can you make a negative lithium ion? Sure. Now, come to find out, that lithium is going to have a really hard time to hang on to that extra electron, so it won't probably hang on to it very long. We'd say it has a really low affinity for electrons. So this is the way we represent the different isotopes for this stuff right here. You can tell from the mass number and what it is, you can tell how many protons, neutrons there are, and then from the charge, you can then tell how many electrons it has. Now, one of the things we have to have about this is the way we would have to sketch something like this. Let's get rid of that electron. We go back to our neutral atom. You have to have some understanding. Whenever we have a model, there's some limitations in it. Here's a problem with this, right? There's the nucleus, right? If I try to draw this to scale, where would the nearest electron be on average? Now, sometimes it can get that close. That would be super close to the nucleus. But this, so right here, I'm at the school. If that was the actual nucleus lithium, the nearest electron, let's see, probably past Marshall Street and maybe as far out as Frandor. Definitely 127. Okay, it's going to be quite a ways away. So there's tremendous distance between these electrons in the nucleus. We do expect that you understand that. Now that's on average, because we're going to find out later, we don't know exactly where those electrons are all the time. So that's the stuff that you need to know about this. Also make sure you understand, if I'm forming ions, okay, we do that by gaining or losing electrons. We never do it by doing anything in protons. That may seem simple, but when you're doing fast multiple choice questions, that ends up being a gotcha kind of question. Okay, that's it for that section.